Hi everybody, I know it's been a really long evening for all of you guys, but we are the last presentation, so I promise we'll make this worth your while. So we have impact of genetic mutations and on mortality rate in breast cancer patients for group 1, and this is presented by Prakul, Balaji, and Sarah, who's sadly not able to be here with us today, but we'll move on anyway. Okay, purpose and introduction. So I know another group already explained this before, but I just want to give like a refresher. What is breast cancer? Breast cancer or breast carcinoma is basically a type of cancer that originates in either one or two of the breasts. And what type of cancer it is dependent on obviously where it is in the tissue. Around 1 in 8 women, that's a staggering 13%. They can contract this disease in the US at least, and that's why it's a pressing problem that needs to be addressed. Some factors that can accelerate this rate are early menstruation, late menopause, and etc. And another group already went over this, but these are the 3 main types, and this pie chart shows how common they are. Going from most common to least common, we have IBC, ILC, and DCIS, but the main thing you need to know is that their names are different because they originate in different places on the breast.
Okay, now we have the purpose. So our main purpose was to examine the relationship between these gene mutations and how they affect the death rate and the survival outcome of our cancer patients. And we also used some bioinformatic tools like Python code, Jupyter Notebook, and cBioportal to analyze this huge data set and get the exact information we need to make our research. And this research was also to help us enhance our knowledge on how these gene mutations do affect the prognosis of these patients. And this leads us to our research question is what are the most common gene mutations in breast cancer and are they associated with patient survival? Okay, so the impact of this study was supposed to be that there are many gene mutations that are very well known by people and they're significant in the survival outcome for patients as well. But there's also many understudied ones. So they would also have the same amount of significance and impact for the survival of our patients, but they're not as well researched. So by identifying these genes, we wanted to make our research helpful so that doctors could be able to identify this aggressive cancer earlier on and help our patients live a longer life.
Okay, so our abstract, basically a summary of everything that we did in our research study. Basically, we just tried to analyze if there was a correlation between how rare a gene was present in a patient and if that had anything to do with their mortality rates. Okay, so materials and methodology. So these are the 2 main files that we use for research. One is a clinical data file, one is a mutation file. All you need to know is that these files contain patient information that helped us find out whether a gene had a high or low mortality rate. So this was our process that we used. We used Python, Jupyter Notebook, and then obviously these libraries like Pandas, Seaborn, and Matplotlib, which basically help us visualize the data. So what we did is, based on the patient ID, we analyzed 3 main factors, which is count, mutation, frequency, calculating the death percentage per each gene, and then we filtered the genes. So there was like 10 main ones that we focused on. So as you can see in the bottom, there's top 10 most frequently mutated genes to analyze the rarity, and then the top 10 genes with the highest death rates to analyze the mortality. And this is just the code that we did. As you can see, we analyzed the top 10 for each of those categories. And yeah, this is the code. We obviously got to analyze the actual mortality rate, so this is the code for the percent of deceased people per mutation. Now let's move on to the results.
After we conducted our series of coding, we created 2 graphs, with the first one discussing the top 10 most frequently mutated genes in our breast cancer cohort, with the y-axis being the different types of gene names, and the x-axis being the number of patients increasing in integrals of 50. It's important to notice here that the 3 genes that stood out and were most prominent in our breast cancer patient cohort were the PIK3CA, TTN, and TP53 genes, as they were found in around 335 to 385 patients. Our second graph, we analyzed the top 10 mutated genes by death rate, starting at a minimum of 10 patients, but relatively staying around that number. And again, the y-axis being the different names of the genes, and the x-axis being the percent deceased increasing in integrals of 10%. What's important to notice here is that the RNF17, MDM1, and TYK2 genes were the most involved in this chart, with around 60% of patients with these gene types passing away. On the contrary, the top 3 genes from the most frequently mutated genes chart, PIK3CA, TTN, and TP53, were not found on this graph, indicating they may not be more lethal, but the overall top 10 most frequently mutated genes did not end up on this chart at all, indicating that these have a low mortality rate or none at all. Through our data analysis, we can further conclude that not all common mutations are deadly. Even though they were the most prominent in our breast cancer cohort, they did not appear on our mutated genes by death rate chart, indicating that they may not be the most lethal, but they were the most prominent, and they may not be a reliable indicator of mortality, answering our research question. However, the mutated genes by death rate chart, the new genes that emerged did come out to be the most lethal, as 60% of patients with these genes have passed away. But they were the least common, as only a minimum of 10 patients or hovering around that number have them. And they can be indicated as critical biomarkers for high-risk breast cancer. Even though they're rare, these genes may require more attention in the future because of how dangerous they may be to patients. And an overall theme that we can conclude from our data analysis is that frequency does not always equal priority. Just because there were many genes commonly mutated in our breast cancer cohort, if we're discussing the issue of survival rate in breast cancer patients, the more rare genes did happen to have the more dangerous mortality rate on breast cancer patients. So these should be more considered in further research as well. And in order to target this issue, we recommend targeted screening for patients with these rare genetics, as well as patients may benefit from more closer monitoring and individualized treatment catered towards their conditions. And in order to provide the most adequate care, we recommend further research on this topic and drug development for each of them.
Okay, so as we wrap this presentation up, we have 2 main concerns. One of them being that majority of our data came from more American and European countries. So this, just because these gene mutations affect one group of people one way, doesn't mean they affect every single group of people the same way. And for our second concern, it was that we might have missed more rare conditions while we were doing our analysis. So more technology in the future, we hope could help solve the situation. And for our 4 recommendations before we wrap up, our first one was to expand globally with our data sets. The second one and the third one were to help doctors create more personalized patient care, because some gene mutations do act in pairs and they can also affect on how the patient takes the therapy. And our last one is we wish to have more technology that can go through these larger data sets more efficiently and more quicker, so that if there's any hidden patterns in these data sets, that we can find them quicker than we do as regular people. So these are references for our research. And for acknowledgements, we want to thank our team manager, Datanova, for all the help he helped for our presentation. And thank you, Datanova, for giving us this opportunity. Thank you.